Okay, so I'm just going to start with my virtual machine, and we're going to start writing this example. All right, so it's recording there, so I'm going to go ahead and start the VM, and maybe we'll finish this one just to get a feel for it. But let's start the VM. I think it started. Oh, there it is. All right, let's give it a minute. The code, as usual, is on the GitHub, so you can just get it from there. Um, So that's fine. But really, the key thing is, you want to understand what's happening, given that, several assignments are related to this. Right. So the topic here is going to be just the XOR operation. And that obviously in the context of some kind of XORing of two sequences of bits, which is essentially some type of encryption. We will need one library which is the OS library Python. So OS stands for operating system. And from that, we're going to import the urandom library, which is, for random, getting actual random values itself. So just give me a second. Okay, there it is. So what's nice about this, it does build up a little bit on your first Python assignment. If you remember in your first Python assignment, we used the ASCII table and we used the functions ORD and CHR. So we will be using those again. It's taking its time to. Right, so let's see. Here's the terminal. Um, Similar idea. We're going to create a couple of functions, encrypt, decrypt. We're going to have now, I'm not like using strings to create the key. Instead, I want to use XOR. Therefore, I have to use byte arrays, right? So we need to actually create in Python, a byte array is essentially a sequence of bits, right? And so that's, so we can do the processing. So we do ls-l cd desktop. Um, so I'm going to cd into fall 2025. It's just a folder that I'm using this semester. I'm going to create a new subdirectory in there because, look at how many files we already have. So this I'm going to put under just XOR example. So I'm going to do mkdir, and I'm going to call it XOR first, for instance. So this is just our very first thing. We're going to create a key that you can now use. So now I can give you an assignment where I say work with a partner, generate a true byte array as a key of this length, send it, and then do some encryption. All right, so you can now do this. And of course, I need to give you the XOR operation, which is just a little caret symbol. Shouldn't have that somewhere. So I'll look for it. All right, so let's do the folder now, cd into it first. Do you guys have a question? Yeah, so yes, stop me if you have any questions, but yeah, the VM, right? So we're in the VM, open a terminal. I'm just going to write a Python script like I did with the substitution cipher. It should be pretty short, 20 lines of code or less, pretty easy, and is very consistent. So ls-l, all right, hit clear. All right, so now just Nano, that's kind of my favorite editor. You can use VI or whichever one you want. Let's give this a name. And remember, this code is on the GitHub, right? So you just go to XOR hash. It's there. I'm just going to call this XOR first example. Example.py. XOR first example.py. Open it, kind of the same structure. I've been saying the word random a lot, right? So you probably intuitively now know that all these algorithms need to have some kind of a random generator, some way of getting that. So the operating system, Python through the operating system can get something like that. So I'm going to do from OS import something called urandom. All right, so this should be installed already. All right, then let's think about just the structure of what we need. We're going to need a few functions just like before. Most of the time, these are the functions we're going to need, right? So we need to encrypt. So then we're going to need, and let me actually note this down. Okay, so we're going to define a function called encrypt. Encrypt. And this function here will take various parameters such as a plain text, a key, etc. But for now, let's just leave it like that. 1, 2, 3, 4. Return. And then I'm going to do the decrypt function, define decrypt, and 1, 2, 3, 4. This is return as well for now, right? So I'm just laying out the structure. This I already did in the last example. This one's a little, now I'm going to add a new function that we are going to need all the time, which is how to generate the key, right? So we're going to need to have some kind of a key. So I'm going to call this one gen key, and we're going to see various ways in which we can do this. Let's actually do lowercase here. Gen key. And gen key, the only parameter that is going to take usually is a length parameter. So that just indicates, the length that we want for our key. So I could say, for a homework, make sure that it's secure enough, minimum of so and so. All right, so this is the function for generating the key. 1, 2, 3, 4, and just some return for now. So that's essentially all the functions that we need. Then we just specify our structure, right, of what we're going to do. So I'm going to motivate the XOR operation with something like a plain text. So let's do the main section. So this is the main. Okay. And I'm going to have, let's say, a message. So I'm going to create a plain text message. Plain text. And I'm going to just say something like, this is a top secret. And just something that we can encrypt via XOR. So we are entering in this example, the actual modern cryptography world, right? Not unlike the substitution cipher. So we can print it. So we can print the this. Plain text. I also, because I don't want to do blocks right now. So I don't want to do blocks. I just want to show the XOR. So I'm just going to create a key that is the same size as the original plain text message. That just makes it easier for now. You can think of this as being one block. Later on, we'll go over that. So then I need length to be len. Len is the Python for length of the variable plain text. And then we can also print the length just to see it. And this should run, so we can try it out. All right, just like that. All right, so I've just added those few parameters. Let's go ahead now and run this script. So you should do Python 3 here probably. And there it is. So this is a top secret, and that's the length. It's 20 characters. Okay, so now we are ready. Let's do something interesting, and let's see if we can't create the key itself. All right, so go back to the code. We are going to need this function now, gen key, so we need to define it. We know it takes this argument. So we can give it a note here, generating the key. Okay. And we just use the function urandom. So this library that I imported here can do the job for us, right? So we're just going to invoke urandom, and we're going to give it as a parameter the length. You guys see that? And then once that's generated, we're going to typecast this generated value as a byte array. Okay, byte array. And that should be it. So this is equivalent to the zeros and ones that we did by hand and XORing zeros and ones. Okay, you don't actually see zeros and ones, right? Because it's just the underlying values in the actual memory of the OS. And remember, when they come out to the terminal, they're converted to strings. So, but it is bytes essentially. So let's try it. Let's see if it works. So I need to invoke this function down here and print the result. So usually we're going to call the key, just with the word key. So that's my key. And then I'm going to call gen key. And I'm going to provide this length, so length, just like that, right? And that's my key. That's the thing, the secret, the thing you need to protect, actually, right? You shouldn't share that with anyone. And when you want to establish communication across the insecure internet, you need to exchange that security. So this is going to be, now we can just print it. Print. That should work. Let's run it. And there it is. Do you see that, guys? So it's actually showing it to you as a hexadecimal. You see that? That's the interpretation that you have of the object. But that's it. So now what you have to do is you create your key, and every string that you have to also convert into a byte array. And then I'm going to show you guys how you do the XORing operation. Okay. And from there, everything is going to be built to work. This is, of course, a Python implementation, so this is not meant to be very fast, right? So if we were implementing this to be fast, we would implement this in C and do actual C XOR operations. But, you can implement that for your term project if you'd like. Here, I'm just trying to show you how it works. So it's Python is not as fast as other languages. Any questions so far? All right, so I think we're ready then. I have the key, I have a plain text message, so I'm just going to go and encrypt, right? So I'm going to do the cipher. So I'm going to create a cipher here. And this cipher, we call the function encrypt. Encrypt is going to take as input the plain text message, which is currently a string, so we need to address that. Plain text message, and it's also going to take the key itself. And we need to be able to XOR both of these. So we need to define now encrypt here. I'm just going to call this one plain and this one key. Okay? So now we just have to perform the encryption. Yes, please. Yeah, sure. Yeah, of course. Good. Yeah, perfect. All right, so now let's go ahead and encrypt, right? So, this is a simplified way of doing it. There's more efficient ways, probably, but this should illustrate the process. 1, 2, 3, 4. I'm going to use a for loop, essentially. And this is called, by the way, if you've never seen this before, when you put a whole for, you guys do a for loop and then several lines and something like that. That's a regular for loop. When you do the whole for loop as one line, right, it's called a list comprehension in Python. It's something you can do. So easy to pick up. All right, so I'm going to iterate. So I'm going to create a list here. I'm going to create a list. and I'm going to iterate through the plain text message. So that's the thing that I want to encrypt. So I'm going to do for I in range. And what's the range is going to be the length of the plain text message, right? Because I'm going to iterate through every character, very similar to what we did in the substitution cipher. Almost the same thing. So I'm going to do here length of plain. And that was 20, I think. All right, so now the I is the index that allows me to iterate through it. And so what you do in a list comprehension is you do the for loop, and what would go underneath will go in front of it so that you can do it as a one-liner. So now the easy thing is I'm iterating through the plain itself, I. And so you're just essentially here iterating through that plain text index by index. And because all of this is being done inside a list, then it starts to become it's like an append of elements into that list, but in a very efficient way in one line. All right, so now you can see, okay, great. I'm able to iterate through all the letters in plain. And obviously I want to XOR each one of those with a key, which is of the same size, so they already match. Any questions? No questions? All right, so what is the XOR operation? Believe it or not, it's just this one, the caret, as it's called, the little caret symbol. It's like a little, it's over the number 6, right? Over the number 6. Okay, so that's the caret. So I'm going to XOR that letter in the plain with my key. Now, my key is already of the proper size, and it's already a byte array. But the problem I have is that the letter is not. So I'm going to, oh, sorry, mine. We're almost done. So the only thing I'm going to try here. Yeah, it's turned. Okay. So the only thing I'm going to do here is I'm going to convert that letter using my ASCII representation. And we already did this in the substitution cipher where I introduced the functions ORD and CHR. So we're using them again. ORD. But we only need to do this for the plain text character like that. So now you can see, I run this plain, the letter through the ORD, get the equivalent number as we did before, and I can XOR that with the key itself. Got it? Not the most efficient way of doing it because for loop, imagine if it's long as going one by one. There are better ways of doing this. NumPy comes to mind, obviously, things like that. But this should illustrate how it works. All right. And then once we do this, we want to take this list comprehension that we're creating and convert it again. Because by doing this, I'm doing a list, which is not a byte array, right? It's a list essentially of maybe bytes. So I need to convert it into not a list, but an actual byte array. So I'm going to do typecasting here and just do byte array. For that full list. And that should be it, hopefully. So that is essentially the XOR operation. Okay, so let's try this out, see if there's any errors. So let's go back. So once I encrypt the whole thing, I'm returning it a cipher. So I want to take a look at it, right? I want to visualize it, see what happened. I'm going to do Control X, Y, Enter. Now I'm going to run it. What do you guys think? Did it work? Did it crash? It worked, right? And you can see they're different. One byte array. What's the first byte array? That was the key. What's the second byte array? It is actually XORing the plain text with the key itself to produce the cipher. Okay? So now we have a building block, one of the most important building blocks in the course, right? So obviously we'll stop here for today, but on Thursday I will pick up where I left off in this code. What do we need to do next? Decrypt, right? So we're going to have to reverse this process, decrypt, and hopefully we'll know it works because we get this is a top secret back out again. But that's your first algorithm where you have implemented a modern, cryptographic primitive. And then from here, we can build XOR hash, we can build CBC, ECB, and all the other. All right, guys. Yeah, please. Yeah, sure. And let me just end the video here. And then... All right, guys. So that's it for today. I'll post